In this video, we learned to recognize the difference between alcohol, ether, and thiol functional groups within molecules. We'll also look at a brief introduction as to why these three types of molecules are important in biology and other applications. Let's go ahead and get started with this. We define alcohol groups as structures where we have an OH group, which we can also synonymously refer to an OH anytime we see it as a hydroxy group. In an alcohol, that hydroxy is bonded to an R group, where the R group is a carbon with some hydrogens bonded to it. That particular carbon that we refer to here can be just about any carbon, but it can't be a carbonyl carbon, a carbon-oxygen double bond, because if it was a carbon-oxygen double bond, then what you would have is this carbonyl group directly connected to an OH group, and that combination of atoms we refer to as a carboxylic acid group. So be aware when you are looking for alcohols that the hydroxy group, the OH group that we see in the structure, can be bonded to a variety of carbon chains, rings, or branched groups, but it just can't be directly bonded to a carbonyl group, because if it is, that makes the structure referred to as a carboxylic acid instead. Alcohols are really biologically prevalent molecules. Some examples of ones that we have certainly heard of that many of us have around our homes include isopropyl alcohol, or IPA for short. Isopropyl alcohol is the common name for this molecule. And quite possibly you have a bottle of this in your medicine cabinet because it has strong antiseptic properties that also result in it burning if you put it onto open skin. Ethanol, of course, is another example of an alcohol molecule. Ethanol is the alcohol that is consumed recreationally. By the end of this chapter, you will understand why the consumption of ethanol in relatively low quantities does not generally have long-term negative health consequences. But on the other hand, if methanol is consumed, which lacks just one carbon atom from ethanol, ethanol has two carbons in its chain, methanol has one, methanol is highly toxic, resulting in kidney failure and a variety of other problems, even when consumed at very low quantities. So later on in this chapter, we will understand that there's a specific type of reactions that alcohols undergo called oxidation that will allow us to explain why ethanol is much, much, much less toxic than methanol. Now let's take a look at another functional group that we cover here in this unit with alcohols because of the structural similarities and hence the similarities in some of the physical and chemical properties. And that group we refer to as a thiol group. A thiol group has an R group, which we can define as a carbon and whatever else we have along in the chain there, that is directly bonded to an SH group, where having that SH group allows the structure to be referred to as a thiol. Just like in the case of alcohols, the carbon here that is bonded directly to the SH group cannot be a carbonyl. If we have a carbonyl group directly bonded, and that carbonyl group is bonded to the SH group, that particular structure is not referred to as a thiol. So be aware that if you see this type of structure, where we have a carbonyl bonded directly to an SH group, that is not a thiol. It's a functional group that's outside the scope of the material that we're covering here. So be aware of that possible red herring. A thiol is referring specifically to an SH group that's directly bonded to a chain of carbons, a ring of carbons, or some sort of branch structure where ultimately it has to be a carbon and hydrogens directly bonded right here at this first position. The thiol group we cover in parallel with the alcohol group because if we take a look at the periodic table, what we see is that in the periodic table that I've brought in here, the sulfur atom is directly below the oxygen in the same periodic table. In other words, they are in the same column or the same family of atoms. And hence, due to the fact that they are in that same column, we anticipate accurately that alcohol groups that have an OH and thiols with SH exhibit similar behaviors and types of reactions that they will undergo, and in terms of their physical properties such as boiling point and melting point. So we can expect these groups to exhibit similar physical and chemical properties. There are some distinctions between the two, which we will get into in later videos within this unit. One distinction between thiols and alcohols is how thiols are received by our smell receptors and taste receptors relative to alcohols. Thiols have a reputation. Specifically, the reputation is they have a reputation for smelling bad. In fact, a substance called ethane thiol, which has a 2-carbon chain with a thiol group here, named ethane thiol, and we will get into the nomenclature of these molecules later on in this unit. Ethane thiol smells terrible. And in fact, the strong scent of ethane thiol, even at parts per million concentrations, is why this substance is added to natural gas to give it a distinct odor that is quite unpalatable, so that we will be able to recognize if there is a natural gas leak within our homes or businesses. In contrast, we don't generally recognize the corresponding alcohol molecule, ethanol, which also has a 2-carbon chain, as having a bad smell. Generally, we would describe the odor of ethanol as being sort of neutral or maybe a little bit on the sweet side. Certainly not the same type of odor that we detect from ethane thiol in natural gas. Thiol functional groups are common in protein, and protein is one of the components and the main component that makes up human hair. And the types of reactions that thiols will undergo, including oxidation reactions, will later on in this unit allow us to understand the chemistry behind why hair curling agents and hair straightening agents are able to work. Finally, last but not least, the third type of functional group that we feature in this unit are ethers. Ethers will have an oxygen that is sandwiched between 2 carbon atoms, where, following the general theme that we've seen for both thiols and alcohols already, the 2 carbon atoms here can be a lot of different things. They can be rings of carbons and hydrogens, chains, branched chains, but what they cannot be is the carbons that are directly connected here cannot be carbonyl groups. If you had a carbonyl group on one of those sides, for example, if we had R as our generic space filler, carbonyl, and then oxygen and carbon, this group we would refer to, rather than as an ether, this would be named an ester functional group. I know the terms ester and ether sound pretty similar, but they are quite distinct in terms of the types of physical and chemical properties they have, so we need to be able to recognize them separately. So our ether functional group is going to have this carbon-oxygen-carbon bond. It's an oxygen sandwiched between 2 carbon atoms, and there are a variety of different ether structures. One application of ethers is that ethers were the original recognized anesthesia agents. Specifically, the molecule that I've drawn here, not my poor rendition of a bat, or if I drew a face on this, a bunny rabbit. This molecule, called diethyl ether, was the original old school anesthetic, and still, if one were to breathe this in, it would definitely have a strong anesthetic effect, could certainly make someone pass out if inhaled in sufficient quantities. Diethyl ether was eventually phased out as an anesthetic agent for a variety of reasons. One of those is that diethyl ether was highly flammable, and back in those days, smoking in the medical facility was fairly common, and there were more than a few accidents along the way with unsuspecting person lighting up a cigarette, not realizing that there was a cloud of ether in the room. So since that time, we have developed a variety of safer practices for applying anesthesia. So with this information regarding the generalities of alcohols, thiols, and ethers, what we will do in the upcoming videos is we will look more closely at such aspects as how to name these molecules and what types of reactions these molecules will undergo to better establish some of the unique biological properties of these compounds, such as why ethanol is relatively non-toxic compared to methanol, and the chemistry of how hair straighteners and perms work. Stay tuned for the later videos to get the full scoop on this.